Hello everyone, I am Jerin. Title of my today's presentation is Investigating Urban Monsoon Linkage on Rainfall Modification on the National Capital Region, NCR Delhi. And I sincerely thank my professor for her valuable support and suggestion during this study. As the urbanization is expanding globally, it is appear to be changing the natural landscape and perturb the surface energy balance. The urban settlements are more prone to the floods and its effects more than the rural regions. And we know that the localized circulation patterns are affecting these micro level climates of the urban regions. And the monsoon weather is attributed to the uh, evolution of cloud systems, humid environment, and shift in the wind patterns. And variability of monsoon and its changes are indicated by its monsoonal rainfall and monsoonal winds, or we call it as monsoon low level jet. National Capital Region of Delhi is situated in the north central region of India, and it's enclosed by in northern Gangetic Plains. And according to the Master Plan of India, we are reaching around 80 million in population, and by 2030, the National Capital Region will be the biggest urban settlement globally. And we can see the land use land cover map, which shows that there is the where the land use land cover changes and urban buildup is shown. In past one decade, we are facing lot many waterlogging flood kind of events. So these are the titles of the daily news reportings in past one decades. We are noticing it. This Landsat imagery shows the urbanization happened in how intensely happened in past 3 decades of time. And urban heat island effect is widely studied and well known, and we know that it is significantly warmer urban core region than the surrounding cropland or surrounding rural regions. Similar, like other cities, the UHI over Delhi is also widely studied and documented in several studies, and which says that the land surface temperature increased around 4 to 6 degrees Celsius, and ambient temperature of 2 to 4 degrees, and also magnitude of wind speed is decreased around 2 meter per second. And the urbanization impact on rainfall modification, or we says that urban rainfall modification, which is from a urban landscape, we know that due to more roughness elements, it affect the wind flows over the urban cities, and UHI triggers a lot of perturbation in the urban boundary layers. And due to a lot of anthropogenic activities, we have more aerosol loading as well as GHG emissions. Apart from that, the surface flex gradient at the edge of the urban to rural surroundings, and rural areas are more enriched with the moisture. The earliest known studies suggested the factors which influence the urban rainfall modification are thermodynamic effect leading more cloud activities and more cloud instabilities, and other one is the thermodynamic and mechanical effect, which produces a confluence zone where the clouds and rainfalls are more initiated. Apart from that, as I mentioned earlier, the aerosols and GHGs and other anthropogenic activities add up giant nuclei for the coalescence process in the rainfall activity over the urban regions. And one latest study came up with the reviewing around 48 works, showed around 18% of increase of the rainfall happened in the downwind side as well as 16% increased in the urban center. Further, in the latest IPCC report, suggests as an emerging issue of the urban regions are generating increased precipitation over and the downwind of the cities. As I told mentioned earlier that these rainfall patterns or modifications are driven by the wind systems, And during the monsoon, we have monsoonal winds, or we call it as monsoon low level jets. The monsoon low level jets carries the moisture from the northern Indian Ocean region to the Indian mainlands, and it's a main driver force of moisture supply for the monsoonal clouds or stratiform clouds. The orographic friction, the diurnal variability, variation in pressure, and regional environment significantly affects and influence the variability of MLLJ, and it has a strong regional and local changes, as we see some of the previous studies across the Indian region, which shows that it is the range of the core of the monsoon low level jet is very near to the surface, around 1.5 to 2 kilometers. That means that the monsoon low level jet is prone to the strong surface forcings, and especially like the urban regions have urban heat islands, and it triggers perturbations also affects the monsoonal winds. So, data and methodology. Our analysis is basically during the monsoon core months, and we have analyzed 30 year of data sets. For the analysis purpose, we have divided these 30 years into three consecutive decades, and other statistical techniques are used to analyze, and the data set used are shown in the table. So now coming to the findings and discussions. Here we can see the time height cross section of wind speed. We can see the variability of monsoonal winds happened in first two decades, and in the recent decade we can see that the wind patterns has been reduced significantly. While seeing the core of the monsoonal winds, it's near 900 hectopascal level, and it's significantly the strength of the monsoonal winds have been decreased to the third decade. And similarly, we can see a directional shift happened in the monsoonal winds, and a marginal reduction in core height is also notable. And the variation of wind speeds in at the 900 hectopascal, that is at the core speed of the monsoonal winds, we can see a significant reduction has happened in the final decade. Similarly, at the surface winds, the patterns has been changed, and it's it has reduced the strength of the surface winds as well. Temporal variation of monsoon rainfall is showing that the trends of the rainfall has been reduced in the latest decades comparing the initial two. Around 28% of reduction is noticed from the first decade to the latest decade. In order to understand the periodicities and intensities of rainfall changes, we have made a wavelet analysis using Moorlet wavelet, and we understood that the periodicity of the rainfall has been reduced to 1 to 4 days in the latest decade, whereas in the previous two decades we have 1 to 16 days band. That means we have less rainfall days in the latest decade. And in the spatially, when we check do that in the first and two second decade, we have more rainfall distributions, whereas in the reduced strength of monsoon we see a certain patterns across the center region of the urban, as it's notably the modifications happened in the monsoon. So, in order to see in detail the what is the changes happen, we have made use of finer resolution GPM dataset to analyze what is the patterns happen. We can the above row which shows the LST distribution. We can see the clearly the urban heat islands during these July, August, September, July, August, and September. Similarly, in the down we can see the rainfall patterns, and we along with the urban heat island we noticed it island of rainfall, and during the September we found several islands downwind and upwind directions as a signal of urban rainfall modifications. During August, it is we know that the LST difference, that is UHI, is about 2.5 degrees Celsius. It's along with the UHI we found a island of rainfall of enhanced precipitation. And in order to check the imprints of what kind of monsoonal periods we have more kind of these episodes, so we found that most of these rainfall islands are formed during the weak monsoonal periods or at the withdrawal spell. And a conceptual model we have derived that the moisture carried by the monsoonal winds triggers the cloud systems by the enhanced heating and the UHI triggering, and it forms the significant modification to the monsoonal rainfall over the NCR urbanization. And summary says that the study identified the signature of the urban environment on altering the spatio-temporal pattern of rainfall. And during the core monsoon period, we have identified the rainfall islands over the urban center, whereas during the September or the withdrawal spell, we have identified the several islands across the urban center and upwind and downwind directions. So NCR monsoon periods of rainfall enhancement and perplexing the spatial patterns suggest urbanization influenced the unfolding monsoonal stratiform system approaching the NCR Delhi. So these are the references. Thank you. And if you need to know more about this work, I have put the paper in this QR code. Thank you.
So question.